Hi, I'm Umnik. I will be doing second division the first round 1051, and I'll try to explain what I'm doing along the way. Problem A, all length subtraction. You are given a permutation P. You must perform exactly one operation for each integer k from 1 to n in that order. Choose a subarray, I'm assuming continuous, of p of length exactly k and subtract 1 from every element in that subarray. After completing all n operations, your goal is to have all elements of the array equal to 0. Determine whether it is possible to achieve that. Well, since we're doing n operations and in each operation we can decrease every element by at most 1, it means that we have to include the number that was like initially n in all the operations. Which means included in the first operation also, the first operation only covers that number. Then after the first operation we only have n minus 1 operations left, so we will have to include two largest elements in that. Then we will decrease them, we will have three numbers n minus 2, and in the remaining n minus 2 operations we will need to include all of them, and so on. So we just need to check that for every k, if we look at the k largest elements of our permutation, they are a segment. And for example, we can just like maintain the leftmost of them and the rightmost of them while we're going from like the largest and two largest, three largest, and so on. So in decreasing order, we're iterating our elements, maintaining the leftmost and rightmost, and then we need to check that the distance between leftmost and rightmost is like exactly what it should be if it is a segment, right? Right, so read n, then read the permutation and store for each number the position of that number, then go through numbers in the reverse order from the largest to the smallest, maintain leftmost and rightmost position, and check that everything is good. So I'm remembering that the number x was on position I. L is the leftmost position of one of the elements I have already considered. R is the rightmost, and now I need to check that since this should be correct. Okay. If x is n, then L and R are the same, so this is 0 and this is 0. And then this increases by 1 when we decrease x, and this should also increase by 1. Problem B, discounts. You want to buy n products with prices AI. You can either buy product I individually, pay in AI coins, or use a discount voucher to buy it as a part of group purchase. If K discount vouchers with values BI, a voucher of value X allows you to select any X products and pay only for the X-1 most expensive ones. As such, you can consider that the cheapest product in the group is free. Each product can be included in at most one discount group, even if it is not the free one. Also, any single voucher can be used at most one single time. What is the minimum total cost required to purchase all n products? Well, just from logical perspective, it seems that I want to use vouchers with smaller values because that is more profitable. Like I can not pay for the more items and also more expensive items. And also it seems that I need to like sort the items in the decreasing order of cost and then just apply the vouchers as they go, as I have space. I don't know, like I think proving it strictly will be a huge ordeal. Like you probably can do like all the exchange arguments, but because like you can choose which vouchers to use, you can choose to which subsets apply. Like it will be a pain in the ass to prove it strictly. but in this situation, I'm just willing to believe that like it just seems the most optimal thing to do. Like I'm usually against applying such logic because a lot of the time you don't have the like right intuition, but well, I don't have any good arguments that wouldn't sound like I'm a dick. Although I am a dick, so I will just say that I think that my intuition is better than 99% of Conversus users because I don't use it recklessly. Like, if I intuit something to be correct, it is more reliable than just if someone says that they think some greedy to be correct, because like I don't usually believe in greedies. Even in the correct ones, I don't believe a lot of the time. But yeah, I don't want to even try to prove it strictly. So I will say at the start that I will pay for all the items, but then I will subtract the items that I'm not actually paying for. Um, So I sorted A in the decreasing order, B in the increasing order. So I first want to apply the voucher for the smallest number of items to the most expensive items and go in that direction. So I will go through vouchers and like P will basically store the position of the first items that I haven't yet used up. So by using the voucher of size like BI, I will process the next BI items. But for the last of them, the cheapest one, I'm not paying, but that happens only if I had enough items. So that would happen if P is at most N. So if P is greater than N, I will break from this cycle because I cannot use any more vouchers anyways. Otherwise, I will subtract AP minus 1 from answer. Problem C, max 3. You're given a tree consisting of n vertices numbered from 1 to n. Each of the n minus 1 edges is associated with two non-negative integers x and y. Consider a permutation of the integers 1 through n for an edge uv such that u is smaller than v with associated values x and y. Its contribution is defined as follows: x if pu is greater than pv and y otherwise. Okay, so u is smaller than v, so if those values, if those positions are an inversion in the permutation, we add x, otherwise we add y. Okay, the value of the permutation is the sum of the contributions. Your task is to find any permutation that maximizes this total value. Well, since it is a tree, I feel like we should be able to just maximize every edge independently, right? Just start at some vertex and then we will basically we will insert values one by one when we're doing DFS. When we go into the new vertex, it only compares with its parent right now. It will also compare with the sons, but we will assign the sons values later. So when we go through an edge, we will insert this new vertex in the permutation such that it is it gives bigger value for the edge. Okay, that's all good and nice, but I need to actually output the permutation. And the simplest way to do what I wanted to do is quadratic, kind of. But I guess if I will use a deck, because I only care about inserting it to the left or to the right of some particular position, but I can just insert in front or in the back. So I need to have like push front and push back, which is a deck. And yeah, that would be it. I guess you can also just like assign direction to every edge by saying like directed edge means that this value should be like smaller than this one, and then you want to find a topological ordering. It surely exists because like it is a directed acyclic graph because the undirected version is acyclic. So like after assigning directions, there's surely no cycles. Like even like going up against the direction cannot produce cycle except like going back and forth on the same edge, but we cannot do that obviously after assigning directions. So you can just like assign directions that maximize the value and then find topological ordering. It is kind of simpler in terms of like it is a standard algorithm, and you just like, basically you read it as a directed graph. You just say like, okay, we read VU and then two values that will look like which value is bigger and direct the edge in that order. Now we have a directed graph, just find topological ordering, that's the answer. It is simpler in terms of like, if you know what topological ordering is and you know how to find it, then you just implement like standard algorithm. It might even be in your library or something. I wanted to say that just doing GFS on tree is simpler. I don't think it's actually true. But since that's the solution I have come up with first, okay, I will implement that. I don't know how to use the built-in deck. I know that it is like kind of slow, but the limitations are small, and like making it 10 times slower is still fine. But like when I need a deck, I usually just write it on an array, especially like if I just need an array that can like insert in front and insert in back, but like I know the number of insertions will be limited on both sides, and then just we'll have an array. I will have pointers to front and back, and then like I will start like in the middle of the array, and when I need to insert in front, I will do like L minus minus. Well, I need to insert in the back, I will do R plus plus, and like my deck will be like some subsegment of this global array. I will not run out of space on both sides because like I just reserved enough space basically. Okay, as always with permutations, I don't know if I need the direct permutation I'm constructing as the inverse one. I think the inverse one, because like I'm I'm determining the order of vertices, but in this permutation, like we are looking at position, like what value is written on the vertex, and so like I will have the order of vertices in my deck, and then I will need to assign like the position in that order to the vertex and print that. So like after finding my deck, after doing the DFS, I will need to construct like the inverse permutation and print that. But this time I also I'm confused which direction I need to do. I'm tempted to just do something, and then if it is incorrect, then print the reversed array. Okay, I will try to figure it out. UVXY. Let's say if x is greater than y, then I want x, and that means that PU should be greater than PV. So I want to, if I'm going from U to V, I want to. Okay, first let's change the order here so that I'm not getting confused by that also. If I'm going from U to V, I want to insert V at the front. Okay, so the case I discussed is when x was greater than y, that would correspond to t equal to 0. Otherwise, t is 1. And like when I go from U to V, I like in this case I want to insert V at the front. So I will say GU pushback VT and GV pushback U equals 1. So if I'm looking at an edge and this is 0, I want to insert in front, and if it is 1, I want to insert in the back. Doing DFS on tree by storing the parent. If like going through edges, if I want to go to my parent, then don't do that. Otherwise, if e second is 0, then I want to insert in front. Otherwise, I want to insert in back. Okay. I need to construct the inverse permutation. That's like this, and print that. 5 4 1. Okay, here I constructed something else. Okay, and it is incorrect, right? Like 1 and 5 should be in the same. Oh no, it's not the it's the inverse permutation. So I need to look at the values on those positions. So 3 4 should compare the same way as 1 4. Okay, 1 4 should compare the same as 3 4. 2 4 and 2 4 and 5 4 and 5 4. Okay, so that's correct. I hate permutations. I figured during my long career. I just hate how I cannot tell if I need like the permutation I have or the inverse in any situation. Okay, problem D, which is split into subproblems. Inversion graph coloring easy version. This is the easy version of the problem. The difference that in this version n is up to 300. Can hack only if you solved all versions of this problem. Sequence bi is called good if there exists a coloring of each index I in red or blue such that for every pair of indices I smaller than j with bi greater than bj, the colors assigned to I and j are different. So if some pair is an inversion, they need to be differently colored, but we color only in two colors. So if we have a decreasing subsequence of size 3, so basically we build a graph on the positions. There is an edge if those positions are an inversion, and we need to color that into two colors. And if there is a triangle in that graph, it's clearly impossible. And triangle in the graph corresponds to having a decreasing subsequence of size 3. Okay, you are given a sequence AI, compute the number of good subsequences of the sequence, including the empty subsequence. Okay, so the subsequence is good if there exists such a coloring. Okay. So if there is a subsequence of 3 decreasing numbers, it is not good, surely. Is it true that it is a criterion? Like, is it true that if we don't have a subsequence of decreasing subsequence of size 3, then it is good? I think so. Basically, that would mean that the coloring exists if our graph is bipartite. That's like the definition. And the graph is bipartite if there are no odd cycles. And if we have yay, balloons. I want to say that like on every edge there is like a big element and a small element, because like the edge corresponds to an inversion, and so the left one will be big, the right one will be small, and this being big or small is a characteristic of the element. Because if we have an element that is big and small at the same time, it means that this element like has a bigger element before but also a smaller element after, so make a subsequence of size 3 that is decreasing. And since now like every element is either big or small, or it is just does not make any inversions, which like we can just say that all of such elements are also big. Now like this is a two coloring, valid two coloring. We only have edges between big and small elements. So like I constructed a valid coloring in two colors. So the graph is surely bipartite. So in this problem, I need to count the number of subsequences of my array such that it doesn't have a decreasing subsequence of its own of length 3 or more. So here n cube is good, and here I need something better than n cube. Okay, well, n cube is easy, right? We can do dp that stores like I want to try to find subsequence of length 3 as hard as possible, and like for that it's kind of like maintaining what is needed for algorithm for finding largest decreasing subsequence, which is like what is the biggest number I have seen and what is the biggest number I have seen such that it has a bigger number before. So like what is the largest number on which a decreasing subsequence of length 2 can end, and that will say that like I cannot take any smaller numbers because that will make a decreasing subsequence of length 3. And the first one I need to update, like if I take a number that is smaller than the largest I have seen but bigger than the largest on which decreasing subsequence of length 2 ends, then I need to update that. So my dp state is prefix, the largest element I have seen, and the largest element on which decreasing subsequence of length 2 ends. And like I can make the transitions in constant time, so it's n cube. And to get n square log, I just need to like add some Fenwick or something, or I don't know. Well, I'm pretty sure I can do that with like some segment trees or something. Okay, let's write D1, and then I think I will just move on to problem E, and then like if we have enough time I will come back to D2 and write some segment tree. I guess I don't need that. don't need to store the array. assuming that the elements are up to n, and they are. Yeah, it's fine. Okay, so I guess I can also add that y should be strictly smaller than x. If y is greater than z, that's bad. Because like by taking that element, I mean, okay, I can obviously just not take that element every time. So let's make that transition. Now I want to take element z, but if it is smaller than y, it means that I will have a decreasing sequence of length 3, which is bad. Otherwise, if that is smaller than x, it means that x and z will be decreasing subsequence of length 2, and since z is at least y, like that's my new state. 1xz. Otherwise, I need to replace x by z. Well, that's weird. At least I should have this. Oh, but okay, so that's like n cube clearly, but like we could try to do this DP like in place. I just start 2 layers, but we can just start 1 layer and do transitions inside of that layer, because like we always, like when we do this types of transitions, we only increase the values, and we can see that like those transitions are some kind of prefix sums. So okay, but maybe I can do something like some actual prefix sums or something. But then I would need to recalculate them, and that is not very nice. But if I just have like fanvic3 by this coordinate and fanvic3 by this coordinate, then it's probably fine, because like I don't need to iterate over x and y like right now. Instead I can say okay, let's iterate over x and see what we are adding to this state, and then let's iterate over y and see what we add to this state. And like both of those will be some segment sums like over other coordinate basically, and we can just take it from fanvic. I mean, yeah, that should work. Will be n square log. Okay, that should be fairly easy to implement. So I'll have fanvic over mint. Okay, so I think I want to have helper function that will add this w to like dpxy, but dpxy is now stored in two spaces. It will be like axy and byx. So it's just called add. So that's initialization. I'm keeping like this thing because I want to re-implement the same thing but using like smarter data structures. So I want to like look at what what additions I should do and just write them in the new language basically. But like the idea of the code stays the same. So now I don't need to do this because I'm just doing it in place. So increase here. So first of all, it happens only for x greater than z. So also, like, because I'm doing in place, I want to first calculate all the changes, write them down in those arrays, and then run again and do the actual additions, actual changes to the DP. So I will clear those arrays now. For x that is greater than z, in position xz, I want to add dp xy for for y that is not greater than z. So ax is x is constant, so I'm taking the sum in the Fenwick that corresponds to fixed x. Get sum from 0 to z plus 1 not inclusive. Okay, and now over y that are smaller than z. B of y is get some. So I want to take sum of dp xy over x's. What? They should be at most z. Like if x is greater than z, then I'm doing this. If they're equal, then if x is less or equal than z, then I'm doing this. So the right border will be z plus 1 again. The left border should be well, kind of y, but also just from 0 is also fine. Like if x is smaller than y, such dp should not exist. So it should be 0 always, and it's fine. Okay, so I found those things, and now I can run through them again. And actually at point x, z, ax. Should it be inclusive here? I think it shouldn't matter. Yeah, I think that it shouldn't matter. Now just collecting the sum of all values. but like I'm storing them twice, I need to take the sum only once. So only over one of them. It doesn't matter which one. They should store the same table just in like, on different coordinates. But just take it once. Is it still correct? And I have changed the constraints to 2000. Yeah. Problem E, my good. You are given a bracket string s of length and you can apply the following operations. So we're choosing two consecutive elements that are opening bracket and replacing with closing and vice versa. So we're choosing two equal consecutive elements and flipping both of them. Okay. Find the regular bracket sequence t, which can be obtained from S by applying the operations described above, or print -1 if there is no such t. Pretty cool. That reminds me of like a famous encoder problem where you also like you had string of letters A and B. You can take two A's and replace them by B's, or you can take two B's and replace them with A's. I think that it was like that in that problem. Or maybe it was the other way around. But the point is that yeah, I think in that problem you could like remove two A's and two B's or something. Whatever. The point is that the amazing idea from that problem is to flip all characters on odd positions, and then like two consecutive positions are always one even and one odd. And since we only flipped odd elements, now instead of taking two consecutive equal values, we're taking two consecutive different values and flipping both of them. But flipping both of them is the same as swapping them. So now our operation is take two consecutive different elements and swap them. But we can also allow ourselves to take two consecutive equal elements and swap them because it doesn't change the string. So we can just take two consecutive elements, doesn't matter if they're equal or not, and swap them. And then like it's obvious that we cannot change like from which characters our string consists, but we can change the order of the characters, and like it will stay the same always. what am I saying? The order will not stay the same. The multi-set of characters will stay the same, and the order we can get anything because we can do transpositions of two consecutive elements that is enough to get any permutation. So if I take elements on odd positions and flip them, then I can rearrange my opening and closing brackets as I wish. But then I need to take, I need to flip elements on odd positions back. And after all of that, I want to get a regular bracket sequence. It feels like I should just do some greedy, like I want to put opening brackets at the start and closing brackets at the end, if possible. Okay. Since there is like another parity constraint, well, it's not another parity constraint, it's just just a parity constraint that exists in the problem. And I feel like if I check that, it works, then everything should just work out. So the parity constraint I'm talking about is that we can calculate the total balance for the initial string, and the thing is we're always changing that total balance by 4 with our operations, because here we're replacing 2 opening brackets with 2 closing, so we're taking 2 plus ones and replacing them by 2 minus ones, that minus 4 to total balance, and this one changes it back to plus 4 to total balance. So if the total balance initially is not divisible by 4, then it will be impossible to make it 0. But if it is divisible by 4, I feel like well, I feel like it should be just true that well, obviously the length of the whole string should be even, but I think that after my transformation, after I flip the odd characters, I feel like the number of opening brackets will be even and the number of closing brackets will be even. Because basically changing if all of the brackets are opening, for example, it is good, because that corresponds to the string being open closing open closing open closing. I will flip all the closing because they're standing on the odd positions, and everything will became open brackets. But now if I change one, I'm changing the total balance by 2. And if I change another one, I'm changing it by 2 again. And so to make total balance to be divisible by 4, I will need even number of changes. And so the number of both opening and closing brackets after the transformation must be even. And if that's true, then I think it should not be hard to just do some simple construction. If all opening, great, it just works. If all closing, then it's impossible, because the first character will always be closing. There is only one way to arrange all the closing brackets, and after I transform it back, the first bracket will still be closing, so that's not a correct bracket sequence. But if I have non-zero of both types, then I can put open and then closing at the start, and then closing and open at the end. After the flip, it will become open open at the start and closing closing at the end. So now I created those buffer to not go into negative balances, and now I can just put like pairs of open, 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 and then closing, 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 closing. And like that thing will just, like, after I flip back, it will be either open, close, or close, open, which like will do plus minus to balance or minus plus. But since I'm at 2 at the start, it will either be like 3 2 or 1 2, and then it returns back to 2, and I'm just, it's just will, it will be good. Okay. So that feels like such a smart solution for this problem. Probably there is something much stupider. But I'm gonna stick with that. Because this is amazing, frankly. It's a bit loosey-goosey on the proof side, but I think it should work. Didn't exactly actually look at the size. Yeah. So I just want to count the number of opening and closing brackets after I do the transformation. And that just means if Si is opening XOR I and 1, A++, otherwise B++. So if I is even, then I'm not flipping it, and like this will be 1 if and only if this is an opening bracket, so I'm counting opening brackets. But if it is odd, then I'm doing the flipping, and this will be 1 if and only if this is closing bracket, which will transform into opening, so I'm adding it to the opening brackets, otherwise to closing. Okay, if A is odd or B is odd, then it's impossible. If A is 0, it is also impossible. If B is 0, means that I only have opening brackets, and it is just like open, close at the end. So I'll just print that. Otherwise, I have at least 2 opening and at least 2 closing. So I will use 2 of each at the start and at the end. So at the start I will have 2 opening brackets after the transform back. Then I'm placing all the remaining pairs of opening brackets, which is like this. then all the remaining parts of closing brackets, which is like this, and then two closing brackets. And like, I'm actually sure, I don't know if like it is needed for the intended solution, but I'm pretty sure that the authors of the problem know about this transformation because that's how the checker works, right? They need to check that the given string and the resultant string can be transformed into one another, and I'm assuming they do it by like flipping all the odd characters and then checking that the multi-sets of characters are the same. Uh, because like I don't see a better way to do it. Actually, I don't see any other way to do it, to be honest, because like it is needed. Like I have shown that there are exactly n plus one classes of equivalents of the strings, like depending on after the transformation how many opening and closing brackets there will be. Like that number is invariant, and like we can achieve any other string with the same invariant. So those are the classes. So that's how you would check that two strings are in the same class. Um, Absolutely amazing problem. Like that original coder problem was even more amazing at that time. Um, but this is amazing use of that concept. I'm very glad to have solved this problem. Not in terms of like that I was able to solve this problem. It was not hard for me, but I was very glad to see that problem. That someone said this problem. It's really cool. Okay, and I have the last problem. Left problem F increasing XOR have been gifted a magic sequence of integers A. However, this is no ordinary sequence. It can modify itself in a specific way. After observing it carefully, you discover the rule it follows. Repeatedly, two indices are chosen. They can be the same, but I is not greater than j. Then the value at index j is updated as so it is being XORed with AI. So if I choose I equal to j, then I can make any element to be 0, but also I can like, take an element and XOR it with something to the right, or XOR it into something to the right. Being afraid of strictly increasing sequences, you start asking yourself questions. Given q queries, each query consists of two integers L and R, and you must determine whether the subarray from L to R can be transformed into a strictly increasing sequence by applying any number of the described operations only within the range L to R. That is only using indices I and j between L and R. Okay, so just take the corresponding subarray and want to know if it is possible to make it a strictly increasing sequence. Strictly increasing. Wouldn't I just be able to like basically for element j, let's just consider the whole array. Don't not bother with queries for now. For index j, it cannot be changed using the later elements. It can only be changed using the previous elements. But I can use any subset of them. Like if I want to take this element j and XOR it on some subset of previous elements, I guess including the j itself. Like I can XOR it with itself first. If I don't want to have a j, but then I can XOR it on any subset of previous elements, and like it doesn't change how I can proceed with later. Basically, I will set elements to what I want, right to left. Take the rightmost element. I wanted to set to XOR of some subset of elements, and that's the only thing I can do. But for any subset, if I want, I can do it. So I can set this element to XOR of some subset, and then just forget about it, because like it cannot be used to change the previous elements, and I have already set it to something that I want. That's it. So for every element, I can just like make it to be any XOR of any subset of elements before it inclusive. Okay. So if we go left to right, now we will like insert new elements in the set of like what I can use to construct the elements. And like what I can construct from those elements is like it's a linear subspace. Well, if you don't know, you won't understand what will happen in the rest of the solution, but I don't know, maybe you have seen like the blog, some like interesting technique for XOR problems or something. But like XOR is addition on vectors over the two, and like the elements, if I have some elements that I can take XOR of some subset of them, the numbers I can get form a linear subspace in that thing. And so we are going left to right and inserting elements, and like our linear subspace will increase somewhat, like at some operations it will not change if that element was already constructible. But if it was not constructible, then it will increase in size like 2 times actually. And like those rank increases can happen only 20 times. So like if we didn't care about the queries, we just wanted to answer one query, we would want to do like some kind of greasy, just go left to right, maintain the set of elements we can construct, and then like for every position choose the element that is strictly greater than the previous one, or 0 for the first position, and constructible using the current elements. and we just want to check if we can always choose that element. Why we want the smallest? Because like it will give us more freedom later. Um, so yeah, but that is like we cannot do that uh, for every query just like that. We can try to do something better. Well, if that's really the solution, it's pretty cool, but also it's been difficult for the second division contest. Uh, and it is not considered like very expensive. Like D2, no, like problem D in total is 2750 points, and it is like considered harder than E. Well, that's insane. And F is not considered like much harder than E or D. Is it really? No, okay. Okay, this is more reasonable to me. Like, yeah, E is much harder than D2, and F looks much harder than E. Mm. Like I'm sure I can do n plus q times log, well, of something. Like, uh, let's just say log n plus log of those numbers in some power. I don't know if I can do it in small enough power. Okay. We have array. have a segment. We want to go left to right, and like insert elements in the set over which we like constructing linear span. And I want to find the the moments when the span changes. Actually, so like we start by like inserting some element. Can we have zeros? Like it doesn't matter. No, non-zeros. Okay. So like the first change will happen like after we insert the first element. But then maybe the next element is equal to the first element, and like I already can construct it, so it doesn't change anything. So okay, yes, the first change like after the first element, then there will be like another place when something changes, and so on. The number of such changes is bounded by 20. Let's say that k is 20, which is like the number of bits in the numbers we are considering. So in our numbers, there are like at most 20 bits, so this bit k is the number of bits. And so each time we change something, the number of numbers we can construct is increased 2 times. So like the number of changes is bounded by k. Okay, so we will have like long segments when no changes is happening. If we did a stupid solution, we like we have a current linear span. We know what is the value of the previous number. We want to find the next number that is like bigger, smallest possible, and constructible in current linear span. So that would be slow. But what if we have a long stretch when the linear span stays the same? We know our current number, and now like several times we will do this operation of like finding the next element in the linear span, and then the next, and then the next, and so on. I want to do that several times fast. I want to say, okay, I want to do those jumps like m times. What will be the number I will end up with? For that, basically, what I want to be able is to like imagine which numbers are constructible, then like find the low or upper bound of the number I'm starting with, like find the position, then add m to that position, and then figure out what was the number on like this position plus m, maybe -1. If I want to do it m times and I took an upper bound, then like for m equal to 1, it will be the upper bound. For m equal to 2, it will be +1 from that, and so on. Yeah, so m upper bound plus m minus 1, I guess. And both of those things are possible if I have like my linear span in good representation as a like basis, and moreover I want my basis to be like in some nice form, basically want to have the largest free bit and like some bit changes from there. So there will be some independent bits and some dependent bits, and dependent bits will only depend on the larger independent bits. Then like to get, so basically okay, if I write the numbers with higher bits on the left, as we normally do, I want my bases to be some zeros here, then there is a 1, and then like all the next basis elements they will start further, so it is in this like ladder form. So this is the next one, is also all zeros, and this is also a 0. Like I can always achieve that. If it was 1, I can replace this number by XOR of this number with this one, and it will still be a basis, but now I will have 0 here. Here we have something. Then we have 1 here, 0 here, 0 here. All of those are zeros. Have something here, and so on. Those are not zeros, those are something. But all of those are zeros. And then if I want to find like what is the 5th smallest number that is representable in this basis, assuming that I'm indexing from 0. So there is like 0 smallest, then 1st, 2nd, and so on. What is the 5th? Then I just need to look at the binary representation of 5, which is 0, 1, 0, 1, and say that okay, I'm not taking this, I'm taking this, I'm not taking this, I'm taking this. Why is that? Well, because if we look at the independent bits, those are independent bits, like I will basically, those are the things that we can control. All smaller bits only depend on the higher bits. So if we want higher bits to be something specific, then smaller dependent bits are fixed. And basically, like if I'm not taking this value, then I can only construct 8 different, but they all will be smaller than if I do take this, because like if I do take this largest basis element, then it will have 1 in this highest position, and if I don't, then it will have 0 there. So that's how I compare them. Basically, I compare them by, do I take this first one? If I do the same with the first one, then I compare them by what I do with the second one, and so on. Okay, so there is a simple way to find what will be the m's, like what will be the number on some position in the sorted array of like everything I can construct for that basis. Can I simply like understand what is the position of the upper bound? Well, like you can do binary search basically, but actually there is like linear of size algorithm that basically you do like binary search but smartly. You just like you want to see what is the smallest number that is greater. So basically, like doing the binary search is the same thing as like choosing each bit left to right, and you can do it. um, so okay, assuming I have this basis representation, uh, it has like size of k, and I can skip this whole group in like O of k times. So if I have all the bases, I think the plural of bases is bases. Bases. Like, I think this is the correct plural form. Then I can solve the problem like by spending another linear of k time on each one. I can answer query in k square, basically. K square is good, and like it is very, it's also very light logarithms. I'm just I have a array of length logarithm, and I'm doing some force on that array. Like, it's super nice. But how do I get the basis, and how do I understand like what are the positions? I think I need some kind of like segment tree that will store those bases, which is already not very nice. Although there are no updates, so the construction is just nk square. Nk square is fine. But then, like, basically, what I want to do is just like start going left to right, but I want to skip to the next change. I want to find where the next change will be. And that will be like some descent on the segment tree. And so if I'm staying here, I have my current basis. Then I will find like the next node that starts from here and like goes here. For that node, I have its own basis, and I need to check if in that basis, like if I can construct something that is not constructible with my old basis. I don't see how to do it like faster than just take all the basis elements and check them one by one. So that is even like k to the fourth, or like k to the third times log n. Like every next change of which there are k, I'm finding in like binary descent on the segment tree, and one check if I need to go deeper in that node or not is another k square. That's a lot. Like, I think even k cube is. I mean, those logarithms are quite small. So, with k cube, I think it could have been alright. this multiplied by 20 cubed is just above a billion. We have 4 seconds. I think it could have been borderline, okay? But the force power is just too much. Can I do it better? Can I do it differently? Can I don't know, offline do something? I don't know. What if for each element? Oh, that actually can be good. For each element, I can try to find like what is the closest to the left position such that this element is representable like only through this as a linear combination. Then for each element I can store that position, and then to find the changes I just need to find the closest element which is not representable through my current elements. So like this arrow leads like further back. Like if I pre-calculate this somehow, I will be able to find all the changes like very fast. The next change is just finding the next element that is greater than my left border, which is just binary descent on like segment 3, which is on just minimum. So I won't have this at all. Pre-calculating that, like, it shouldn't be hard, to be honest. Something like stores the basis that is like as much to the right as possible by doing scanline left to right. Um, when you like find new element, you try to represent it um, with your current basis. Um, then look at the leftmost element you used and replace it with the new element. Yeah, so that should be doable. But probably not in 15 minutes. Yeah, I think that works, and that would be just like log squared, which is actually a good complexity for this problem. Like, I think log cube can pass if you're brave enough, but log square is just a good complexity. Nice problem. It's complete insanity to say that it's just a bit harder than E or D2. I mean, saying that D2 is harder than E is also insanity. Um, but whatever. Yeah, F should have been much more expensive, I think. Maybe I'm missing something simple. Also, maybe like some. I mean, most of the ideas I have used are already standard. Maybe the last thing is also known. Maybe I just didn't know it. Alright. Uh, I don't have time to implement anything which reasonably can pass. So I guess I'm just. I will just say that I have come up with log square solution, uh, but I don't have time to implement it. So very good. So I guess that's it for me. Thanks for watching. Bye.